Okay, so what if I told you that you could make your own electricity, like right now, using stuff you probably have in your kitchen? I know, it sounds a little like a magic trick, but it's all science. Today, we're going to create power completely unplugged.
So here's the big question, the one we're all here for. Can you really light up a bulb without plugging it into a wall? Or even using a normal battery? I mean, it sounds impossible, right? But the answer is 1,000% yes. And we're about to show you exactly how.
Okay, but before we jump into making our own power, we've got to get a handle on the secret behind the spark. And that secret? Well, it all comes down to understanding what electricity actually is.
When you really break it down, electricity is just the movement of electrons. Seriously, that's it. Think of it like a river, right? When water is flowing, you've got a current. Well, when these super tiny particles called electrons start flowing, you get an electric current. So, our whole mission today, it's pretty simple. Just figure out how to get those electrons moving.
Now, the electricity coming through the power grid to your house, that's a huge, incredibly complex system. What we're doing today? It's the total opposite. It's super simple, it happens right in front of us, and honestly, it's a pretty tiny flow of electrons. We're not trying to power a city here, we're just proving that it can be done. All right, let's get our hands dirty with our first method. We're going to create the simplest, fastest kind of electricity you can actually see with your own eyes, a static spark. Think of this as our instant flash of proof that we can get those electrons to jump. And get this, the stuff you'll need for this is so basic. All you need is a balloon, your hair, or hey, a wool sweater works too, and something metal, like a doorknob or even your keys. That's literally it. This is science you can do pretty much anywhere, anytime. Okay, so here's the play-by-play. First, you're gonna take that balloon and just rub it really fast and hard against your hair. What you're doing is literally scraping electrons off your hair and onto the balloon's surface. Now really slowly bring that charged up balloon towards the doorknob. A little closer, and zap. Did you see that? That tiny little spark is our first win. So what was that? What did you just see? That was basically a tiny, tiny lightning bolt. It was a super fast, kind of chaotic release of all those extra electrons you packed onto the balloon. They just leaped through the air to get to the doorknob, and that created the spark you saw. That spark is an electric current. We did it! Okay, so a spark is cool, but it's over in an instant. It's fast and chaotic. What if we want a nice, steady, continuous flow of power? Well, for that, we're going to switch gears from physics to chemistry, and we're going to build a tiny little power plant out of a lemon. Yeah, a lemon.
So for this little project, our power source isn't some giant plant or a fancy solar panel. Nope, it's just a regular old lemon. We'll also need a copper coin, like a penny, a zinc-coated nail, and a tiny little LED light so we can actually see our masterpiece in action.
Building this thing is super easy. First, just roll the lemon around on a table pretty firmly. You're just trying to loosen up all the juice inside. Then you're going to push the copper coin into one side and the zinc nail into the other. The key here is to make sure they don't touch each other inside the lemon. Think of them as your plus and minus terminals. Okay, now for the moment of truth. Take the two little wires or leads from your LED and touch one to the coin and one to the nail. And if you look really close, the LED should light up. It might be faint, but it should be glowing. A single lemon battery like this can generate about 0.9 volts of electricity. Now, to put that in perspective, a normal AA battery is 1.5 volts, so it's not a ton of power, but it's real, measurable power that we made from a piece of fruit. So what's the trick here? Is it magic? Nope. The acid in the lemon juice is the key. It acts like a special liquid highway for electricity to flow through. It's called an electrolyte. It kicks off a chemical reaction that literally pulls electrons away from the zinc nail and pushes them toward the copper coin. The LED just gives those electrons a nice little path to travel along, and boom, you have a current. So let's do a quick side-by-side of our two methods. The static spark, that was all about a big buildup and then a super fast, uncontrolled release. It's over in a flash. But the lemon battery, that uses a chemical reaction to create this gentle, steady flow of power that can actually last for hours. So yeah, one is a bang, the other is a steady hum. Okay, so we've seen a spark that we made with friction, and we've seen a little light glow thanks to a chemical reaction. On the surface, they seem totally different, right? But believe it or not, both of these experiments work because of the exact same single fundamental principle of electricity. And this really brings us to the one big idea you should take away from all this. It doesn't matter if you're using friction or chemistry, a lemon or a lightning storm, all electricity, and I mean all of it, boils down to this. You just need a difference in electrical potential, a charge difference, and a path for the electrons to flow. So let's circle all the way back to our original question. Can you light a bulb without plugging it into the wall? Well, you now know the answer is a huge yes. By using either a little bit of friction or a simple chemical reaction, you did it. You created that voltage difference and you made electrons move. You literally just created your own power source from scratch.
And that leaves us with a really cool question to think about. We used a lemon, right? But this science works with a potato too, or even salt water. So just look around you. What other everyday things could be a battery in disguise? The possibilities you'll find are pretty much everywhere. Have fun experimenting.